Okay, so in section 9.3, I have a note page that we're gonna go through in a minute, but before we do that, we should talk about how we use Taylor series or polynomials for approximations. Okay, and so let's suppose I said that given the function f of x equals e to the 3x, we're going to find the, we'll do a Maclaurin polynomial. Maclaurin, remember, it just means centered at 0. Of degree 4. Okay. And what we're going to do then is, since it's centered at 0, we're going to use it to approximate f of 1/2. So we can, in the same way like that we use linear approximations, Taylor polynomials can also be used to approximate values that are around 0 in this case, or whatever the center is. So first let's do the process that we need to for Taylor polynomials. So what I'm going to do is I'm going to write down an equation for f prime of x. F prime of x would be 3e to the 3x. F double prime of x would be 9e to the 3x. F triple prime of x would be 27e to the 3x. Okay, and so on and so forth. So you can see I'm using this property that the derivative of e to the x is e to the x, but then we have to use chain rule. So we have to then multiply by the derivative of 3 to the x, which is 3. Alright, so putting it into the form for Taylor polynomials, we need to have f of 0. So going back to the original function, f of 0 would just be e to the 0 or 1. F prime of 0 would be 3 times e to the 0 or 3. And then as I move on, I'm going to find the coefficient. F double prime of 0 divided by 2 factorial would be the coefficient of the second degree term. So f double prime of 0 is 9 times 1 divided by 2, so I'll just leave that as 9/2. F triple prime of 0, we're going to divide by 3 factorial, so we have 27 times 3 factorial. Let's keep in mind that 27 is divisible by 3, so if I took a 3 out, this is 27 times. Alright, so taking a 3 out of top and bottom, we would get 9/2 again. And then the fourth derivative of 0 divided by 4 factorial. Alright, so we would have 81 divided by 4 factorial. If you do some computation with that, you find that it reduces to 27/8. Okay, so then the formula is for any degree f of x, any the polynomial, and this is a fourth degree, is f of 0, so 1, plus 3x plus 9 halves x squared plus 9 halves x cubed plus 27 8 x to the 4th. Okay, so then what we can do, so this would be our Maclaurin polynomial of degree 4. Using it to approximate f of 1/2, we would put it in, alright, let me go back. So, I would say then f of 1/2 is approximately equal to, make sure we use that, p of 1/2, and putting 1/2 into the polynomial. I am sure we could do this exactly, but let's save some time. Okay, so we have 1 plus 3 times 1/2 plus 9 halves times 0.5 squared plus 9 halves times 0.5 cubed plus 27 eighths times 0.5 to the 4th. We get, so 3 decimal places, 4.398. Let's just, for the heck of it, find out what f of 1/2 is using the original function. If I put 0.5 in, I would have e to the 3 times 0.5 would be e to the 1.5 power. Okay, so it looks like we're dealing with an error of about 0.19. So that's the first thing you should be able to do today with using Taylor polynomials, is to do some approximations. And so I am going to have you start with that, and then moving on, tomorrow we'll talk about how we deal with errors and how we write remainders and that kind of thing.